What is the slope for the first one? What is the slope for the first one? -9. How do we get there?
-4 minus 5.
Yes. -4 minus 5. That's part of it. What else? 3 minus 2. -4 minus 5 would give us what? -9. 3 minus 2 gives us 1. And -9 divided by 1 does come out to be a whole number. It is -9. I know I didn't ask you guys for this, but I'm going to take a little caveat for just a moment. Now that we know the slope, could we write an equation with only the information that's up here right now? Yes. What form would make the most sense if I was going to write an equation with this? I would not write it in y equals mx plus b form. You can, but not using only the information that is up here. To use y equals mx plus b, I need the slope, which I have, but I also need to know the y-intercept, which I don't know. What's another form that I could use when I have the slope and any other point? We talked about this 2 days ago. What form can I use when I have the slope and any other point? Anybody remember? Go look in the 90s in your book. The 90s pages. High 90s, like 95, 96, 97. Look around in there. Point slope form, yes. Point slope form, this is the one that was y minus y1 equals m, and then we had parentheses x minus x1. Using only the information that is up on the screen, I can now write an equation for this. So y minus something equals, and then I would put my slope in, and then x minus. What would I fill in these two spots? What would I put in these two spots after both minus signs? Where would I get the information that goes there? You pick one of the 2 points. Which point do you guys want to use? First one, 2, 5, okay? So if we use 2, 5, what do I put right here? Y minus 5. Y minus the y part of the ordered pair. So what would I put here then? 2. Once we know the slope, if we found it from 2 points, we can then write an equation using just that information. What is the slope for number 2? 3/4. Let's talk about how we get there. I know I'm going to subtract 2 numbers. What do I have in my numerator? 5 minus what? -1. What would go on the bottom then? 7 goes right underneath the 5. Remember, if they're on top of each other like this, they came from the same ordered pair. 7 minus what? Close. -1. What happens when I subtract a negative number? Like this? Becomes a positive. So this is 5 plus 1 and 7 plus 1. What is 5 plus 1? 6. 7 plus 1? 8. What can I do to both of those numbers? Not by 10, but by, not by 10, by 2. Divide them both by 2. 2 goes into both of those numbers evenly. And so that's how we got 3/4. Does it matter which order I put the numbers in up here? If I did 5 minus -1 or if I did -1 minus 5? Does it matter what order I do it in? No. Let's test it and find out. If I had -1 minus 5, and then down on the bottom, -1 minus 7. What's -1 minus 5? -6. What's -1 minus 7? -8. A negative divided by a negative gives me a positive. Look, I still got 6/8, which then I can reduce. I get the same answer no matter which order I do it in. You just have to make sure that the numbers that are on top of each other came from the same ordered pair. If you do that, it doesn't matter what order it happens in. Help me write an equation in point-slope form for this. Which ordered pair do you guys want to use? Second one? Tell me why. Because it's positive. I like that. What would it look like if I chose the first one? I would have y minus what? I would have y minus -1 and x minus -1. And then I have to change subtracting a negative into what? Into a positive. If you use the other point, you get an equivalent line. There's absolutely nothing wrong with doing that. I did want to highlight what happens, though, if I have a negative there. So I would have y plus 1 equals 3/4 times x plus 1. All right. Nice work on the bell work. We're going to be on page 103 today, almost the entire time. We're going to do 2 examples today. It should not take us the whole time. So you guys should end up with an extra bit of homework time. When is your next homework due? Friday, tomorrow. Short week, so tomorrow is Friday. If you have fallen behind on the homework, you need to be using this D-lunch study time to catch up on the homework. I am here to help and answer questions. There's no reason to say I didn't turn in the homework because I was confused. I am here at your service. All right, so page 103, example problem number 3. We want to solve this system. We're going to graph it. They have it graphed for us already, but we're going to practice today getting these into slope-intercept form. This top equation right here, what do I need to do to that top equation if I'm going to put it into slope-intercept form? What's the first thing I need to do to it? Yeah, we want to get we want to get y all by itself. So that means I need to subtract 7x from both sides. I'm going to write something down. I want you guys to tell me why it is wrong. Why is that wrong? Yeah, 16 doesn't have an x with it. I cannot combine those two things. So what should I write down instead? Negative 7x plus 16. The 16 is positive. What do I still need to do to this to get the y all by itself? Divide everybody by 2. And so then I have y all alone. Y equals, is 7/2 going to come out to be a whole number? Then I'm just going to leave it as that fraction. You can write it as a decimal if you want to. It'd be negative 3.5. But when we're graphing things anyway, I want my slope as a fraction so I can count my rise and my run. So I'm going to leave it as a fraction here. Can I simplify the back part at all? 16 divided by 2? 8. So there's one of my equations. Y equals negative 7 over 2 x plus 8. So far, so good? Let's do the same thing to the bottom equation. Where would I want to start this one at? We're going to add 21x to both sides. And so I would have negative 6y equals 21x plus 24. Where from here? Divide everybody by negative 6. So I have y is equal to, this is going to be a negative. Yes. 21 over 6 I can reduce. What goes into both 21 and 6? 3 goes into both. So 21 divided by 3, I get a negative 7 here. 6 divided by 3, I get 2. Can I simplify this fraction back here at all? 24 divided by 6 gives me 4. So here's my second equation. Negative 7 over 2x plus negative 4. I want you guys to make a note real quick about this. When you add a negative, that's exactly the same as what other operation? Subtracting. Adding a negative is subtracting. What do you notice about our two equations? They have the same slope. What else do you notice about these two equations? They have different y-intercepts. When they have the same slope and different y-intercepts, what does it look like when we graph it? They have it here for us. Parallel lines, yes. We get parallel lines. So talk to me about solutions then. When I'm talking about lines on a graph and I want to know about their solutions, what do we mean? Where they're touching each other, things they have in common or points they have in common. They don't have anything in common. So what are our solutions then? None. There are no solutions. What about if they had the same slope and the same y-intercept? What would it look like then? Line on top of itself, which would be infinitely many solutions. Remember, when we're talking about two lines on a graph, the solutions are the points that they share, the points that they have in common. If they don't ever touch each other, they don't share any points, there's no solutions. If it's one line on top of itself, they share everything. So there's infinitely many solutions because they share all their points. What about if they cross like this? One solution, because they have one point that is the same between the two of them. Make sense? All right, we've got one last example that we're looking at today. Further down the page, we are going to practice two key skills here. The first one is writing this system of equations. So I want to read through this problem, and I want you to pay careful attention to what we are talking about in this story, because that is going to guide how we set up our equations. Suppose an electric car costs $29,000 to purchase and $0.036 per mile to drive. And a gasoline-powered car costs $19,000 to purchase and $0.08 per mile to drive. Estimate after how many miles of driving the total cost of each car will be the same. What are we talking about in this problem? Miles and cars. Just one car? Two of the same car? Two different cars. What's the difference between them? One of them is electric and one of them is gasoline powered. How much does it cost to own the electric car? $29,000, and that's all I ever have to pay for? $29,000 is just how much I have to pay when? To purchase it. So how many times do you have to pay that $29,000? Once. This is our initial or our starting cost. Does anybody know on the graph where I would see the initial or the starting amount? Y-intercept. Anytime we see the initial amount or the starting amount, that's what goes on my y-axis. That's my y-intercept. So I pay $29,000 for this car and I never spend another dime on it. It continues to cost me money. How much does it continue to cost me? 0.036. What does that even mean? How much is that?
36 cents.
Not 36 cents. It's between 3 and 4 cents. 0.03 would be 3 cents. 0.04 would be 4 cents. So it's in between 3 and 4 cents per mile. So I don't just pay another, it's not $29,000.03, right? What is this information that they've given me here? We said that $29,000, that's the initial or the starting cost. That's my y-intercept. That's my slope. How do we know that this is the slope? There's a key word that gave it away. Per. There are a couple things that will be key words for us that all indicate slope. Per is one of those key words. Does anybody know any others? For each.
I was going to say that.
For every.
Is it the number of? Is that one? Number of?
Not necessarily. I'd have to see it in context. I'm not saying that they would never use something like that as a keyword, but without seeing the rest of the sentence, I can't say yes or no. But things like per or for each or for every, those are always going to be indicating that this value is a rate. It is a slope. So what did they tell us about this electric car again? $29,000. So they told me the y-intercept, the starting amount. What else did they tell me? The slope. What form should I write this equation in? Slope-intercept form. Slope-intercept form. If they gave me another point on here, not necessarily the starting amount, then I would use point-slope form. So if they said, oh, after driving the car for 10 miles, this is your total cost, then I would use my point-slope form. They gave me that initial amount. When they specifically give me the initial or the starting amount, then slope-intercept form is going to be my best bet. So they've got part of this written out for me. Y equals blank x plus blank. What goes on this first blank line? I got the y equals already. Yes. 0.036. This is where my slope goes. Yep, plus 29,000. There's my y-intercept. What does the x mean here? What do they have x meaning? Not per mile, but very close. X is the number of miles. X means the number of miles. What does y mean here? My initial cost is how much? Total cost. Initial cost is my y-intercept. This y is going to tell me after I've owned it for a certain amount of time, how much have I put total into this car. I had to pay that upfront cost, but then I have this ongoing cost that keeps adding to it. So this is my total cost here. Beautiful work so far. All right, so we have our electric car. What else was this story telling me about? A gasoline car. What kinds of information do I have about the gasoline car? Yep, I have my y-intercept. What's my y-intercept? 19,000. That's my initial amount. Where do I put that in the equation? After the plus. We don't put it in for the y. The y is part of my equation. So what goes in front of the x, in between the equal sign and the x? Yes. They gave me 0.08. That is my slope. I knew that because it had this per next to it. So 0.08. You guys okay with how we wrote those equations? All right. When you guys get to the homework, there's a whole lot of scaffolding in your book. They told us what x means. They told us what y means. We want to make sure that you are able to read these stories and write these equations on your own. All right. Now for the solution. They've gone ahead and graphed this for us already. There's their beautiful graph. Ibrahim, is there a solution to this?
Yes.
How do you know? What do you see on the graph so that you know there is definitely a solution? A point. What's special about that point? Yeah, you're still going. What is special about that point so that you know? Yes. Where the two lines are intersecting, this is our solution. Oh my goodness. All right. What is the solution?
The solution is...
How do we determine our solution based on this picture?
Well, you can tell it's between 35 and 40 in terms of cost.
It is between 35 and 40 in terms of cost. Let's figure out how Jaden knew that. Where's cost on here? Y-axis. Okay, so I take this point. I'm going to track it over here. It's fallen in between 35 and 40. If I asked you to estimate that amount, 37 sounds good. Is it just $37? It costs $37 to own this car? How are they measuring things on that y-axis? In thousands of dollars. So all these numbers actually need 3 zeros behind them. They just chopped off those 3 zeros so it didn't take up so much room on the page. So far, so good? All right. I still need the x part of this ordered pair. How can I find that? Yep, let's go down to the x-axis. So I'm going to track it down this way. This one's not as easy to read. I'm somewhere in between 210 and 270. What is this little line right here in between the 210 and 270?
250.
240. How do we know it's 240?
I gotta know it's 240.
Because it's 60.
Oh, it's
Yeah, from 210 to 270, they added how much?
30.
They added 60, but then there's a little line from 210 to 270.
Wait, say that again?
From 210 to
Oh, I
270.
thought you said from 210 to 240. That's 30. You see what I'm saying?
Yeah, but we're not there yet. You asked how we got this. From 210 to 270, they added 60. I have a line that is halfway in between. What is half of 60?
30.
30. So I add 30.
Also off the head.
You were ahead. All right, so if that line right there is 240, is the green dash that comes down right at 240? So ballpark it for me. You think it's about how much?
230.
230 sounds good. So 230 miles? 230,000 miles. Once again, it says they're measuring in thousands, so they chopped off the 3 zeros. I have to put them back on. It says they're measuring in thousands, so I had to put 3 zeros back on the end. This means that after driving about 230,000 miles, the cost for owning each of these cars will be the same. The electric car is more expensive to buy, but it doesn't cost me as much for each mile. The gasoline-powered car is cheaper to buy, but it costs me more money. So eventually these two are going to balance out. How do I know whether or not that's reasonable? What could I do to check to see how reasonable that is? What did we write in Part A? Look in your book. What did we write in Part A? What did we do in Part A of the problem? We wrote 2 equations, right? I can substitute in and see how reasonable this is. You guys have some space off on the margin. I want you to do this in the margin of your page. We're going to check this. What was the amount of miles? What was the X part of the ordered pair that we had? 230,000. What was the Y part of the ordered pair? 37,000. So we're going to take 230,000. We're going to sub that in for X. I'm going to take 37,000 and I'm going to sub that in for Y. We did have to do some estimating on the graph, right? We did our best guesses. So I'm hoping these come out to be equal, but they might just end up being close. Since I had to do some rounding, I had to do some estimation. Yes, sir.
Never mind.
Are you sure? That looked pretty serious.
It said 225, but you said it wrong.
Huh?
Like, you said 230?
Again, I'm going off the guesses that you guys gave me.
Oh, okay.
I know that your book made its own guesses. We're checking our guess. This is why I wanted you guys to do it in the margin of page 203. So flip backwards to where our picture is. We're actually going to do this on page, sorry, not 203, page 103. I want you to do this in the margin there. Grab a calculator for me. Cell phone calculator is totally fine, but I want you to multiply these two together.
Oh, crap.
What do we get when we multiply 0.036 and 230,000? 8,000 what? 280. What do I want to add to that? 29,000. So on your calculators, add 29,000 to that. And tell me what you get. 37,000, how much? 280. What did we have on the other side? What was our Y value? 37,000. Is that exactly equal? Are those completely the same? They are very close. The way I indicate that two values are very close is with a squiggle equal sign. This means approximately. Are these two numbers approximately equal? They're pretty close together. Let's look at the other one. What am I putting in for x again? What are we putting in for x? What was the x part of our ordered pair guess? 230,000. What should I put in for y? 37,000. Grab your calculators for me. I want you to multiply these two together. 0.08 times 230,000. $18,400. What do I want to add to that? 19,000. So add 19,000 to that number. 37,400. Over here we had 37,000 equal. No, close. Yeah, I'm going to say approximately here. The estimated number of miles makes both equations approximately equal.
Excuse me.
Bless you.
So sorry. Be quiet. I used.
So do you think our estimate is reasonable or not? I think it's pretty reasonable. And actually, when I compare our answer to the answer in the book, I think we did a better job of estimating than the book did. We got two numbers on either side in our check that were closer together than the book got when it did its check. All right. That's where we are stopping for today. You guys have the remainder of class time, which is more than 10 minutes, and all of D lunch time to work on your homework assignments. Something I want to tell you real quick about the homework. If you were not here yesterday, please make sure you grab a page of graph paper. There's 6 graphs on a piece of paper up here in one of the trays. You are going to be solving by graphing on 9 of the homework problems, 7 through 12 and 22 through 24. You'll need graph paper for those. 13A and 14A. You're going to practice what we did on the story problem in part A there, where we just practice writing those equations. All right? Let me know if you guys have any questions. And you guys have the rest of the time to work.